Alright, so in this video, we're going to look at this question, and this question is a 2010 JAMB question, question 25. So the question is, what mass of aluminum would be deposited when a current of 10 ampere is passed through a solution of an aluminum salt for 1930 seconds? We're given that the relative atomic mass of aluminum is 27 and Faraday is 96,500 coulomb per mole. Alright, so we have option A, option B, option C, and option D. Again, the question is, what mass of aluminum? So we are looking for the mass of aluminum that will be deposited when a current of 10 ampere is passed through a solution of an aluminum salt for 1930 seconds. Alright, so the first thing I would want to do here is to first of all write a balanced equation for the deposition of aluminum atom or aluminum molecule from aluminum ion during electrolysis. So it's very important that you should know that aluminum is an example of a trivalent element. It belongs to group 3 of the periodic table. So as a trivalent element, it is going to have an oxidation number of what? Of +3. Alright? It's going to have an oxidation number of +3. So aluminum ion, which has an oxidation number of +3, would have to accept 3 electrons of electricity. Why 3 electrons of electricity? Because the oxidation number is what? +3. So it will have to accept 3 electrons of electricity in order to deposit 1 mole of aluminum. Alright? In order to deposit 1 mole of aluminum. And 1 mole of aluminum is equal to what? 27 grams. Alright, so in other words, 3 electrons of electricity will give us 27 grams of aluminum. We're dealing with grams because the question says what mass of aluminum, and our options is in grams, so we're looking for the mass. Alright, so you should know that 3 electrons of electricity will be required to liberate 27 grams of aluminum. We're given the relative atomic mass. So, in other words, 3 Faradays of electricity will be required to produce 27 grams of what? Of aluminum. Alright? So, 1 Faraday is very important that you should know that 1 Faraday is equal to what? 96,500 coulomb. Alright, so if 1 Faraday is equal to 96,500 coulomb, then 3 Faraday will be equal to 3 times 96,500 coulomb, and that will be equal to what? So let's bring out calculator. 3 times 96,500 will be equal to 289,500. So that will be 289,500 coulomb. Alright, this is the value for 3 Faradays of electricity. Alright, so here we have that 3 Faradays of electricity will give us 27 grams of what? Aluminum. So these 3 Faradays of electricity is equal to 289,500 coulomb. So in other words, 289,500 coulomb would give us what? 27 grams of aluminum. Alright, so the question again is, what mass of aluminum will be deposited when a current of 10 ampere is passed through a solution of an aluminum salt for 1930 seconds? So we are looking for the mass of aluminum that will be deposited by this current when it is passed for a time interval of 1930 seconds. So the first thing I would want to do here, or the next thing I would want to do, is to calculate the quantity of electricity that would be produced from a current of 10 ampere within a time interval of what? 1930 seconds. So you should know that quantity of electricity Q is equal to what? IT. Quantity of electricity Q is equal to what? IT. So our I in this question, which is our current, is given as what? 10 ampere. So we have our quantity of electricity now will be equal to 10 times the time is what? The time is 1930 seconds. All right. So times 1930. So 10 times 1930 will give us 19,300 what? 300 coulomb. All right. So if 289,500 coulomb give us 27 grams of aluminium, then what mass of aluminium will be deposited by a current of 10 ampere when it is passed through a solution of an aluminum salt for 1930 seconds? So we've calculated the quantity of electricity that will be produced by 10 ampere passed for a period of 1930 seconds to be 19,300 coulomb. All right. So if 289,500 coulomb give us 27 grams of aluminium, then 19,300 coulomb of electricity would give us 19,000 times 27 divided by 289,500 coulomb. So this will be 1,000, this will be 19,300 times 27 divided by 289,500 coulomb. So if we bring out our calculator and press this will be 19,300 times 27 equal to divided by 289,500. That will be equal to 1.8. So this will be equal to what? 1.8. All right, 1.8. So the correct answer to this question is option C. All right, option C. That's the correct answer. That's 1.8 grams. This is the answer. All right. So 19,300 coulomb would give us what? 1.8 grams of aluminium. That is the mass of aluminium that will be produced when a current of 10 ampere is passed through a solution of an aluminum salt for 1930 seconds. All right. It's a very simple and a direct question. You can always go over the video again and again until you understand it very well and practice with questions. All right. I have a lot of questions that you can practice with. So do make sure you solve questions.